people assume that being a data scientist means that you're modeling the entire time, which is not true. You're modeling pretty much, you're less than like 10% of the time. Most of your work goes in like all the other peripherals, which are equally, if not more, important.
Alrighty, everybody. Hello and welcome to Career Talks with Mentoria. I'm Nikhar Arora. I'm one of the founders of Mentoria. Thanks a ton for taking the time out and joining us in this incredible session. Our passion is to ensure that we're helping everybody discover themselves and figure out which careers they will enjoy and excel at. And through these podcasts, through these panel discussions, through these talk shows, we want to give each of you an extremely realistic understanding of what your career is going to really be about. The more you know, the more informed your career and educational decisions you can make. And today we're going to have an incredible conversation about the world of data science and building a career in it with three absolutely amazing panelists. We have Usha Rengaraju, who's the Chief Data Scientist of Polymath and the founder of NeuroAI. Of course, she's going to introduce herself and share a little bit about what she's been up to as we get into the discussion. We also have Ishita Mathur, who's a data scientist at Phi. She's an author, she's an industry mentor, she's a speaker, and she's also worked with Gojek and Delhivery. We also have Supriya Raman, who's the lead data scientist at JPMorgan Chase and is one of the top 10 Indian women data scientists of 2021. Extremely happy to have all of you with us on this panel discussion. Thank you so much for taking the time out. So let's begin by getting to know our panelists a little bit more. My first question is to Usha.
I wanted to become a financial consultant. So I was into investment banking side before I switched my career to data science. So my passion was all about investment banking and finance. So I accidentally got into data science. And I was my first assignment was about solving problem for, a startup which was dealing with end-to-end trading platform using AI. So they wanted somebody with very strong background in investment banking, and they wanted somebody who understands the mathematics involved as well. So at that time, I was taking a lot of courses in data science. So I was fitting their requirement, and they convinced me to work part-time for their project. And that was my, start to the world of data science. And data science world is a different kind of opportunities for different kind of work you do. So consulting, you have a lot of client projects. So if you're into product development, then there's a very product specific use cases of machine learning. For example, I'm a chief research officer at Exo Protocol right now. So at Exo Protocol, it's a product which involves Web3, blockchain, and all of it. So there are very specific use cases of data science there. So you have cybersecurity and AI use cases. So the work is all about solving the problems which the product might face in the intersection of cybersecurity and AI. But if you're going to be a consultant, the kind of problems which you might be solving is openless or bottomless. Like you will solve problems from investment banking to retail to manufacturing. So you might solve all kinds of problems. So that gives you a lot of flavor, and that also gives you a very good exposure to solve like very, very complex problems. I've predominantly worked both on the product side and the consulting side over a period of time, and this is how my journey started.
See any of these awards or any of these surveys which has been done, the top 10 women data scientists was mainly with Analytics India magazine last year, and I think they base their surveys on social media analytics, what data we share, what kind of contributions we are doing, or what kind of job roles we are holding. But surely I would like to share my milestone, my career milestones with you. So I have 16 plus years of experience in industry, and I have spent most of my time with banking. I started my career with the Washington Mutual Bank, which later merged into JPMorgan, RBC, Royal Bank of Canada, UBOC, Unibank of California, and then ANZ. I spent a lot of time with ANZ Australia Bank, and then now I'm in JPMorgan. This is my whole journey. So as part of a data scientist, I understand there are three important pillars which we should build on. There are data, domain, and then there are technology. Of course, you have to be very strong in technology, no matter at what positions you hold in data. But along with it, domain plays a very vital role. And I'm very fortunate enough because I have started my career with core banking, where I learned a lot about banks. I was in loans and then deposit, CIS, customer information system, and then preferred client. There are modules of that. And now I am in KYC and client onboarding, which is an investment banking part. So building up that domain also makes a vital role in a data scientist region, because the more and more you understand domain, the better it is for you to help you to understand the data. When you are working on any of these models in banking, understanding the end-to-end architecture of a model actually plays a vital role. You cannot just put a model thinking of just a part of it. You have to understand the whole flow of the data. That's some of the major things which I have learned through my career.
Ever since I was in school, for me, physics was what I wanted to do. I wanted a career in academia, physics research, specifically particle physics, which is why I chose to do my undergrad in physics as well. But while during my undergrad, when I did a research project with ISA on experimental particle physics, I think I got more onto the computational physics side of it, where I was working very closely with simulations, large amounts of data. We had to deal with terabytes of data at that point, which I think sort of got me more interested on the high performance computing side of it. How do you optimize for performance when you're dealing with data at that scale, which is sort of what pushed me towards my master's in high performance computing as well. One internship that I did sort of changed the entire game for me. So I think for me, that was one of my primary inflection points. In the University of Edinburgh, it was the program I was at was in the School of Physics. So I could choose to do physics courses as well as data science courses, high performance computing courses, and my minor was in data science. So during the course of the program, I got more interested in the data science side. Getting a job in data science as someone who has no prior experience in data science is quite challenging. But I think it took probably a month, but I was able to find a job. And I worked with delivery for a year. It was super interesting. The team was pretty great. Worked in the logistics sector, then moved on to Gojek, which again happened by chance to me. Moved to Bangalore, worked in ride sharing problem statements, worked with food delivery problem statements. So kind of transition from classical ML to more on the NLP side. And then now at Phi, it's completely more on the natural language understanding side. So while there's also been a transition of one industry to the other, from logistics to ride sharing, food delivery to banking, there's also been a transition in the kind of problem statements and that within data science that I've worked on as well. So I think it's been quite interesting. It's been, I think, 6 years since I kicked off that journey in my career. And there's been a ton of learnings. There's been a ton of ups and downs. So I actually get this question a lot, and a lot of people assume coming into data science that it's going to be 90% or more about building data science algorithms, but that's actually not the case. It's maybe 10% or less actually working on core machine learning AI algorithms. A lot of the other work that goes into data science is about sort of, getting your hands on the data, working with their data, sort of figuring out patterns in that, understanding that data, and then sort of figuring out how do we build a model on top of this data? And then even once the modeling part is done, that's not where the entire data science process ends, right? You have to figure out one, how to productionize your model. How do you actually get the predictions of your model out to users? How do you integrate it with like other system within whatever infrastructure you're operating in? How do you measure the impact? So I think probably a lot of the work that goes into like data science is more around the pre and post model building phases. So yeah, like getting your hands on the data, and then once the model is built, figuring out how the model is performing and getting data from there.
See, when you talk about a data science project, it actually starts with the business understanding. You have the business knows their problem, but they are least bothered how you solve it. Whether you want to put a machine learning model into it or you solve it in Excel, they don't care. They have a problem, whether you can relate to that problem. And as a data scientist, your challenge starts there, because a model which you might have put for one solution, which it will not work for any other data, which might look very similar. So business understanding of the problem is the first thing which you have to crack through. And getting also, many a time the business are not very open to speak. They can't they know everything, but they don't know how to put it to you. So you have to be vocal with your questionnaires, with your you have to be very vocal with how you approach the business. You have to be very sound with your studies which they have, the documents which they have shared, and then ask a lot of questions so that you yourself equip yourself to put the model. When you put a model, how will you maintain your model across time? Because you cannot afford to train it. Now, when you do NLP modeling and all, there are a lot of deep learning model which you put through, and the cost is very high because you generally don't operate on CPU, or you need high-end machines, specifically the processing part of it. So you cannot afford to pre-train your model again or train your model again. You have to maintain your model, and that is again a very crucial thing which a data scientist should know how to do that.
I work with a lot of college students and who work with me as interns, and predominantly from non-computer science. So I think majority of them, 9 out of 10, I think, are from streams which is not related to computer science. So I would say like anybody, even without programming background, can easily pick it up, because the packages and the data science is a bit evolved in certain streams. And at times we have to come up with our own custom architectures. We may not be able to use the existing models as such. There were cases like that as well. So if you're into research, you might be there are a lot of algorithms out there, but you will invent your own custom algorithm. The recent cases for that energy consumption problem, there's a phase 2 of the competition where it is called research competition, where we came up with our own custom algorithms. But for 95% of the clients which have worked across domains, we have used algorithms which had already existed. But for the research, there are a lot of companies which have specifically research labs which are more towards publishing research papers. That's the main, main objective or goal for the research labs, AI research labs of Microsoft or Google Research. The main goal is to publish research papers, solve open problems and things like that. So their main idea is to come up with a custom algorithm. So they are already working on problem statements, which is clearly defined, where they already have data. So the main objective is to invent new algorithms, get patent, publish papers in top research conferences and things like that. So the work might slightly differ from what kind of exact work you're doing, whether it's research or it's just you're trying to solve a business problem out there. So the main parts here is understanding the business problem statement, collecting the data, then modeling it, and try to solve, as Supriya pointed it out, the model which you build, there's a higher probability that it might not perform the way you want to perform after deployment. So there's a lot of drift which happens. Initially, it might work for 2 months or 3 months, and after that, the model's performance starts deteriorating for a lot of reasons. So that's very important to see how your model, monitor your model's performance even after solving the problem, even after deployment. You have to still monitor your problem statement and model. And so this is how I'll explain. You're trying to solve a business problem through AI. So the business problem can be anything, whether it's identifying if it is the signal is coming from an emulator, or if the signal is coming from a real mobile, or if if it's a banking. I've dealt with a banking application where the application actually tracks if it's a real user who is operating the phone or it's a fake user. The application could be anything. You're trying to solve business problems through technology, and the technology here is AI.
So what I've understood is, first, of course, it's figuring out the business that you're in, and therefore what is the problem statement in that business, or what is the problem that you're trying to solve in that domain. Number two is figuring out how to collect the data to ensure that you have the right variables in place. Number three is cleaning that data, processing that data to ensure that it can go into your model, and does it mess the model up. Number four, either building your own custom models, or in using existing algorithms, using libraries that are online to process that data and see why the problem is happening, what are the potential solutions, projecting that data to figure out, okay, this is how we can solve this problem, and then continuously monitoring if that problem is getting solved or not, constantly working on that model to ensure that if any new variables come in, we're able to understand them and solve them. So that's the core of the work. Is that a fair understanding of how it works?
Yeah, you got it right.
One is to have like super solid fundamentals. And the second thing that's required is like a demonstrated experience, like demonstrated exposure or projects that you've worked on. There's obviously two ways that you can go about this. One is going through a formal education program. You do like a university degree in computer science, or with a specialization in data science, or like a degree, like a master's in data science, and so on. So there's like a ton of universities with programs out there in India, outside India. It's totally okay to also go for like an informal program where you're going for like a course on Coursera or Udemy, or just maybe just looking up articles, YouTube videos, learning by yourself. The one thing that I would want you to consider is, between choosing a formal program and an informal program, is how much do you already know about the field? So if you already know exactly what you need to study, then an informal program makes sense. Okay, I need to go and learn up this NLP course on Coursera to give me the knowledge that I need to, like do the things next. But if you want to go into data science, but you're not really sure about what all you need to learn as a part of that transition, then it makes more sense to maybe go for a formal education program where your curriculum is kind of designed for you. You have people who can sort of help you out, like professors, seniors, etc. A very important thing to consider, like especially because when you're transitioning into data science, when you're looking for your first job in data science, everyone wants to talk about what past projects you've worked on, what experience you've had. And that can be very challenging for people who've not done any data science projects because you are a fresher in the field. So I think one thing I would say is, while you're also learning about data science, while you're learning the theory, it's very important to maybe do some projects on your own. Maybe look up data sets on Kaggle, or look at Kaggle competitions and maybe participate in those. Try to build something by yourself that you can talk about, maybe as a part of like a university course, as a part of like a capstone project on an online course. But it's very important to actually put the theory that you have learned into a practical project, so that you can also show and talk about, and that itself will be a completely different learning experience, because you will come across challenges that you may not have considered or thought about when you were just learning the theoretical aspect of data science.
my career, if you see, I stepped into core banking and then business intelligence. We had a lot of projects in RPA and then DevOps, big data lake, or there are a lot of things which you do, and then finally you landed up into data analytics or data science and machine learning. But nowadays you have choice of all these fields. So if you want to become a data engineer, it's a very different stream now. If you want to become a data analyst, it's a different stream. If you want to become a data scientist, machine learning expert, NLP expert, deep learning expert, these are all different streams. These are huge streams. And if you are a fresher, if you don't know what all these mean, because these terms are very relevant in the market, but sometimes we don't know what is the difference between a data engineer and a data analyst. Whether I want to become a data engineer or a data analyst itself is a question. So the best way to understand that is go through the JDs. Start reading the JD at no matter whether you are a fresher in a data science field or whatever level, start reading the JDs. As and when you read more and more JDs, it will be becoming very clear of what these roles demand. And then first figure out what role actually suits you. Also in hand with that is very important, which I will say again, I will keep saying that the business knowledge is very important. So most of these roles which open up, they don't only ask, of course the technology is something, and in technology there are two things. They ask programming skills and the SQL. I will give my own example. I had to land up in Levi's, right? And when I was giving an interview for Levi's, it's a retail business, very different from what we have in banking. So retail goes by recommendation. You have price and promotions. You have traffic forecasting. There are different terminologies. In banking, we don't go by recommendation. You generally don't recommend your customer that you go by this, right? So recommendation is not that strong. But if I have to land in that business, if I want to choose retail as my business, I should understand domain. I cannot go just say, I don't understand what's the recommendation. And it's not difficult to understand with the amount of material we have. So if you want to first choose your domain in which you feel yourself are comfortable, read ample amount of blogs. Also, there are GitHub links where the codes are present. You can download those codes, go through those. In banking, many a time the banks open the hackathons for the general public. So anyone from the industry can come and join a hackathon, although you're not part of that bank. And then you can present your idea, and then you can start contributing there. So I think all those are also very important, other than your technical thing which you learn by the course. And the most important thing, presentation, the way you present. A lot of things, but are you able to convey it? The kind of communication you do is again very vital. And when I say communication, it is about your social media presence, whether you can market your profile properly, whether you can present your strengths properly when it has been asked through. If I Google you or if I search you on LinkedIn, am I able to find you? If I'm not able to find you, that means you are not present there, right? As a HR, if I'm trying to find a proper data scientist who can be suitable for my role, and I'm not able to find you on LinkedIn, I will never be able to reach you. So those also plays a very vital role, I think, nowadays in the market.
Personally, as a hiring person, the main skills which I look for is critical thinking skills. So there were a lot of government projects which we did, which was very high on mathematics side. Still a lot of mathematics which is involved to just pre-process and bring it into a format where you can start analyzing it. So I had to hire people with very good critical thinking skills. And so for some of the use cases, our main objective was publishing a research paper. So in that case, they had to do a lot of literature study. So every day they had to study, every 2-3 days they have to study one paper, understand the terminologies. There's a lot of reading which happens as well. A lot of other skills outside the key programming skills and understanding data science, because the data science, when you take up the modeling part, the packages and all of it is pretty much in a very, very matured stage. Most of the research papers, even as new as 2022, the research papers which are coming out are already implemented by open source enthusiasts or volunteers, or many of the companies do it themselves. And they implemented it and they open source it in one of their favorite platforms. It could be either PyTorch. PyTorch is where majority, around 85 to 90% of the research papers get implemented in PyTorch. It's a favorite language for the researchers, I believe. But I am into TensorFlow, so what I do is I convert these PyTorch papers into PyTorch implementation into TensorFlow, and I contribute that way. There's one more platform which is coming, which is specifically for research, which is Flax and Jax. It's an amazing platform out there. So most of the research papers are already implemented, and you can just use it, consume those research with just few lines of code. If you're starting out your career, the general advice which I would give, you should understand yourself well. What is your learning, what are your ways of learning, what kind of learning really works of you, understanding the psychology of yourself and understanding what are your positives when it comes for learning is very, very important, because you have to choose a learning style which works out for you. So there's a lot of research which goes behind the making of the course. They literally spend somewhere between 3 to 6 months putting in the best minds from the industry and academia. So there's lots and lots of research and the money investment which they put into preparing and curating these curriculums. Self-learning is equally good, I think, but when it comes for hiring, what the hiring managers actually looks for is, are you able to convert this theoretical knowledge and into something more productive? Are you able to apply these theoretical knowledge into projects? So basically, they look out for projects, the kind of projects which you have solved throughout the curriculum. So it shouldn't be like the same projects which your curriculum has. Curriculum might have some capstone projects and they have course projects. If you just put these projects in your resume, what is something new which you have done is what they look for. But the three primary skills is either are you able to apply your knowledge into a real world problem, and critical thinking skills and persistence and hard work, and this is what I look for in a candidate.
When choosing a university, it's about looking at what you want to get out of that university. So one obviously is the kind of program. Is that program allowing for maybe like internships? Do they have like a good internship, this thing? What kind of projects can you work on? Who are the professors who will be teaching there? Are these the kind of professors that you want to learn from? So these are obviously things that are important to look at, irrespective of whether you're studying in India or outside India. Studying outside India, I think a lot of people choose universities outside India because they want to continue to work outside India afterwards. So if that is something that you want, then going for a degree outside India would not be a bad option. From like my personal experience, universities in India would be more of like a classroom, this thing where like you're given lectures and you take down notes and then you have exams. But outside India, the format of teaching itself is very different. Like you're given the notes and everything beforehand, and in the class it's mostly to discuss things on top of that. So you're not really taught things for the first time within the class itself. Exams are not a high priority. Most of you're assessed mostly on coursework that you do, and not just like the projects that you write. Like every project needs to have like a written report along with it, so it also improves like your writing skills, your communication skills. Having studied outside India, I would definitely recommend everyone to have that experience at least once in their lifetime, because it definitely is incredible exposure. But specifically for like data science, it may or may not be required, and it completely depends on what you want. Studying in the UK means you can really specialize your degree program. You can completely customize, like you can do like a master's in artificial intelligence or a master's in data science or a master's in NLP. Like your degree will be that, and then if that is something that you want, if you want that name on your degree, then UK would definitely be like a really great option. Europe as well, like I think they have like masters in data scientists. There's a bunch of really great universities. I think University of Amsterdam is one of them. Looking at what are the job opportunities you can have after studying there is also like another factor maybe you should consider when applying abroad, because studying abroad is expensive, there is no doubt. But in terms of comparing which one you should go for, I think it really boils down to what you want to gain from that program.
Whether you study abroad or whether you study in India, the most important thing is build up your knowledge. Whatever theory which you are learning, can you build up that in practical is more important. And also, thanks to COVID, everything has gone global. You have global teams now. Most of the positions also which open, they don't say location. Of course, you have to mention because that should be in system. But most of the roles also which get open in organization, they have gone global. So you might be working in India and you plan to switch to US. Your organization will be very happy to do that because you have a global team. For example, for my team, I have people in Singapore, US, UK, and then India. Whether you study from any place, you try to build up your knowledge base properly, build up on your practical skills, whether you can implement, try to search for proper projects, and then the opportunities are open everywhere. And if you are the right candidates, organizations are very happy to have you. There are different type of roles, and also these roles according to different organization might need differently, but at a very high level we can classify these roles. And that's why most of the certifications also, the courses also which we have, they have electives where they ask them to choose through these. Some of the roles which are very prevalent in the market, I would like to mention those. One is for sure the data engineering. The data engineering people are the one who deals with cloud or big data kind of thing, because they have to connect to different APIs and get their data on a common platform. The data collection part of it, or getting it from the different sources on a common platform, is something what data engineers do. And that's why they have to deal with structured or unstructured data, a lot of API to connect through, and also cloud. They work mainly on the cloud. Once you get the data onto it, that's where the data engineering task ends. Once they put it in a platform, then comes the people. Either you want to put just a simple dashboard or a data visualization kind of thing, or you just want to gain insights out of data. And such roles which just are without any kind of modeling are the data analysts, who are actually putting dashboards, or they are using Tableau or BI tools, or they are using ClickSense, ClickView, putting the dashboard, or organizing the data in a proper format so that it is presentable to the business. That is what data analysts do. And also data science and ML, even in data science and machine learning, there are different roles now. We also have DevOps on, for that matter, also open. Now, when you say data science and machine learning people, machine learning engineers is also a role where they are specifically asked to put models through machine learning, which can be a very traditional machine learning thing, or it can be even tools which are more aligned to deep learning or NLP, and then there are specializations to all of these. So they are, and then there are also people with ML ops. This is a very new, like we have DevOps, we have also ML ops, which are the people who are mainly for the deployment of these models which you do, and then maintaining it further. So ML ops are the people who actually works on those. So these are some of the very, very different kind of roles which we have, and each of these require a very different kind of skills. So we should be very clear on what we want to achieve in these, and then target those properly.
There is some myths regarding the positions and things like that. So when you take up bigger organizations, they have a very clearly defined demarcation between roles. This might differ if you're dealing with a startup. So in that case, there'll be like sometimes 3-4 people doing all the works. There is no clear demarcation between the roles. When it comes for a very early stage role, you might have to take up anything which is offered to you. But I think there are a lot of job hirings which is happening for a very bigger organizations. It could be any organization which is very stable and has been functioning for a long time now. And you have so many roles. In addition to these roles, you also have roles like data evangelism. And data evangelism is a role where you should have a deep understanding of all of the everything which is happening inside the company, and you should also have a very strong understanding of the product. So the main job is promoting the product. Either it could be in social media, or you should be attending a lot of conferences where you'll be speaking about the product, giving interviews. So data evangelism is also equally lucrative field. And a lot of people just want to become machine learning engineers or deep learning engineers. There are few people who are hesitant towards exploring MLOps side, or they're hesitant to get into data engineering side, or they're hesitant to get into the evangelism side. Irrespective of the job demarcations, anything which you are good in, I think you will definitely get paid. So let that pay factor not be a determinant in deciding which field. So there are so the ones which are not very common, or which has less understanding, are the evangelism, and there's also client facing customer data scientists. There are roles like many organizations have called customer data scientists. This is a role which is coming up in majority of the organization. For example, if you're building an auto ML product, I'm not taking the names of the companies, but if you're building an auto ML product, so there are several auto ML organizations which are some of the top in the field. So they cater to very, very big financial organizations. They're like unicorns with $1 billion evaluations and all that. So these organizations have plenty of roles for customer facing data scientists, and they're unable to fill it up. So there's huge demand in this area, and it's a very well paid job. So you require to understand about everything A to Z about the product. You should also understand everything about data science. So your main job is to interface with a client if there is any new requirement coming up, understanding it and translating it to the technical team in the company. The additional roles which I would like to add is evangelist and customer facing data scientist, and there are roles like this which get equally paid as high as a traditional research engineer or a deep learning engineer or machine learning. The pay here is based on what value you add to your company, how strong are you in the field which you are in. So irrespective of the job description you choose, be strong in whatever you have chosen, and definitely I think you'll get well paid.
I think one of the myths, like as I started with, right? People assume that being a data scientist means that you're modeling the entire time, which is not true. You're modeling pretty much, you're less than like 10% of the time. Most of your work goes in like all the other peripherals, which are equally, if not more, important. I think a lot of people have reached out to me about transitioning into data science because they think it's like the cool thing to do, and they think that it's going to be like an easy journey, but it's not. It requires a lot of critical thinking, a lot of just thinking outside the box, understanding the domain. You're putting on like multiple hats at once, right? It's not just you're a data scientist, you're working as a project manager, you're working as like a leader, you're working as a communicator, you're working as an analyst, you're working as a data engineer at times as well. So there's like a heavy overlap between these things. I think data scientists are probably one of the very few careers out there where it's so important to keep learning as you're working. Like you have to keep, because there's so many new innovations, new technologies, new algorithms, new papers being launched every day. You need to stay up to date, because if you don't stay up to date, you will become extinct effectively. So the knowledge you would have would only be applicable to maybe something that was there a few years back. So it's so important to stay up to date on what's happening. It's important to keep learning about the new things out there. When you're a data scientist, you're a student for life.
There are two things which I like to say. One is there are a lot of people who are working on the legacy systems like mainframe, AS400, or those technology which still exist in the market. They are very relevant because especially if you see banking and finance, they can never get rid of these legacy systems. So there are people who are working on these legacy systems, but they know that they cannot grow in their own field, and they have taken this field. But although they have opted for this field, they're not very sure they can make a transition. They are doing some professional courses, they are at a high-end learning, they are branding, they are upskilling, and they are doing everything correct, but they don't have this confidence that they will make a career switch. That is one. and other one is with the years of experience. So many of the people, like earlier the industry was like that, you have a hierarchy. Now that hierarchy has been broken in many of the organizations. We generally have, you do have a hierarchy because you need a reporting managers, and that way the hierarchy exists. But the hierarchy does not exist that you have a manager managing and then you have people working. It doesn't happen. Managers are generally the technical managers, they have to work themselves also. So in industry, there is a huge chunk of managers who had been in industry for a long time. So that is a very huge myth. You have to really showcase people with the examples of people who have broken this myth. And I actually sometimes have to connect some of my mentees to people who have done it in order to make them understand that this is possible. So those are two myths which I would like to add.
Salary. So people think data scientists or the job roles around data science gets paid high. That might be a primary determinant for them to, take up data science as a career. But being in the hiring space, and company which hires both web developers, Android developers, and data scientists as well. Maybe there's a difference in certain companies, very few or some section of companies, but majority of them, Android developers or a web developer or a software engineer gets equally paid as a data scientist. And sometimes there were a particular section of developers which we required for doing certain thing. We were willing to pay anything to get that kind of a specialist because they were very, for the skills which we required because of the urgencies, and because of that, we were paying like 3 to 4 times higher than what we were paying a data scientist. So let pay not be the factor in choosing data science, because that is changing predominantly, but there could be differences. If you're a data science company, pure, your soul and soul of the company is data science, then they might pay higher for data scientists. But if your company is a product company and data science is one such team, and the dynamics might be different. And so it differs from a certain section of companies still offer higher pay for data scientists, but majority, around I see 70 to 85%, the trend is changing slowly. And the second thing is education. This is going to be a strong point, but education is slowly becoming no longer mandatory. I see a lot of students who are still there in 8th standard, 10th standard, still making huge amount of money than somebody with 3-4 years of experience in data science. So data science, you can be at any stage of a career, even without any formal education. You can still solve data science problems, because the primary motive is you go do a 2 years master's, spending somewhere, if you don't get scholarship, and you spend up somewhere between 40 to 50 lakhs, or depends on the university again, somewhere 25 to 50 it goes. You put in a lot of investment thinking that the country is going to after 2 years you complete, you will get paid very high and all. You can earn the same amount of money sitting in India. I know a lot of people sitting in India that because relaxation policies for working from a different country, you can still be employed in the US-based companies, because there are many of my friends who are working for US-based companies remotely sitting from India. So the relaxation policies, there are different criteria under which your working regulation falls under. So the relaxation policies for many of the countries have changed because maybe it might be because of the COVID and things like that. So you can still be employed for an international organization sitting right in India and earning an equal pay. So there's a difference in taxes. You have spent very less for your regular expenses or living expenses. You can get equally well paid sitting right in India with less living expenses. And the trends are changing. This is a slowly trend which might, become a full-time trend. This is slowly starting in certain section of the companies, which might spread over, and this could be a trend for the next 5-10 years. You might have, watch out for this trend.
One of the primary challenges when getting into the career is most of the job descriptions for data science, if you look at them, pretty much everyone is looking for experience. So as a fresher, when you're trying to look for a job in data science, and then you come across all of these job descriptions that say maybe like 2+ years of experience, 1+ years of experience, 2 to 4 years of experience, it can become very challenging and very demotivating to, especially when you're trying to look for something that can suit someone who's new to the field. So I would say that I think it's okay to even apply to those jobs, even if they say that, okay, we want someone maybe more than 2 years of experience. It's just, like I said, you have to demonstrate your experience through personal projects that you would have worked on. It's not when a lot of these jobs are looking for, like, the interview process will be, okay, cool. Tell me about this project that you worked on. How did you solve this problem? What were the challenges you ran into? How did you maybe like deploy it and stuff like that? So, like, be prepared for those things beforehand, before going into the interview. So build your own projects, maybe create some kind of API where you've deployed your endpoint for predictions. Talk about how you did that, so that do all of the work that you would have done as someone who has 1 year of experience. Do that as a personal project, so that when you're going and interviewing for these roles that require experience, you have that experience equal, but not as a part of like a proper job. There are people who do all the studying necessary, but they're not confident enough to apply because they don't think they've studied enough. I don't think there can never be a point at which you feel like you studied enough. So it's just important to just go out there, start interviewing, applying for jobs, learn from those interviews, take notes during those interviews, and think about the questions that maybe you weren't able to answer, so that you can maybe learn those concepts, think about how to answer them, so that you know better for the next interview that you have. I think most of the challenges that you come across, maybe that I have come across as a part of my career, are mostly like data oriented. Like, how do you make sure that the data is as expected, or understanding the data and just like working with the data just before you even get into the modeling stage. There's a lot of challenges that you will face day to day as a data scientist.
Pre-becoming a data scientist, when you are in a journey of becoming a data scientist, there are pictures which actually scares, where you have data science at the top and it shows a big glacier down, and it says that math, stats, and programming languages, and then it looks very scary when you start, because there are a lot of things which you have to actually grasp in this journey. But it is not all mandatory. It's not that if you're not strong in math or stats, you cannot become a data scientist.
The hiring space I would like to point out, because personally, recently I was hiring for, in the month of February, I was hiring for some internship positions. I got around 450 applications, and out of which I shortlisted to some, I filtered out, in the first round I filtered out and I got around 80 applications. One intern, who was extremely good, because I did not hire him for the first 3 projects. I did not hire him. For the 4th project, when I hired him, I found out he was the best out of all the other, even the previous 3 projects whom I had different candidates. He was the best candidate out of the entire, set of applications which I've got. But why didn't I hire him at the first go? Because of the resume. His resume didn't say anything. He had done a lot of things and he has not updated his resume, he has not marketed it well, So, when you go for, when you put out your resume, and ensure you get it right, put all your achievements. There will be a lot of challenge in data collection strategy. At certain points, you might start with the problem statements over a period of time. This is just my experience, but dealing problems with certain domain. Decision making is a very, very crucial aspect of data science as well, identifying things at an early stage and making the right decisions at the right time also. So there will be huge challenges like the problems which can be solved just by having the right communication skills and negotiations, because you're dealing with people here. So you should know how to deal with people across diverse geographies, and so the people skills matters a lot as well. And for certain kinds of role, the people skills matters a lot.
So one piece of advice for a working professional transitioning into data science, I think I understand that it's also difficult to like learn and prepare for interviews along with your current job. So just make sure that you are taking out time to do these preparations. And as I said before as well, right? It's never too early to start giving interviews, as even if as practice interviews, right? Just start interviewing, applying for jobs, interviewing with companies, and learn from those interviews. You can ask for specific feedback on if they say that we can't continue with this application. You can ask them, what could I have done better, or where did I go wrong, so that you can then use that as a learning experience based on the feedback that you get from your interviewer as well. And yeah, at the end of every interview, always ask questions. Like I've interviewed so many candidates that just don't have any questions for me, and I think for me that is also along with like the technical skills, that is kind of like a culture flag for me. Like this person doesn't have questions about maybe like the work that we're doing at this org, or about the role itself. That can be this thing. So always ask questions at the end of an interview. A piece of advice for students, I think, don't focus too much on the theory. Theory is important, it's very important. Like both Supriya and Usha have said, critical thinking is important, skills in math are important. You don't have to learn everything in order to, feel ready for the job, but it's important to, while it's important to have your theory really like on point, it's also important to have that practical experience by working on those projects. If you showcase your ability to do all of these things as a part of your personal project, I think that makes you automatically even more eligible for a pure data science role per se.
I have spent around 16 years in industry and 8 to 9 years in data. None of the project actually is similar to what I have done in past. So there is learning in each project. Each project will be very different. There are some professionals who are very adamant that they want this kind of work only to be done. Each project has different requirements, and we have to be very flexible, at the same time very innovative with the approach which we are doing. That is very much important. And one piece of advice for the students is there will be a lot of failures. In LinkedIn, it is very common these days to say that I got 4 offers, 5 offers, and 10 offers. But what people don't mention there is how many you failed. If you have 4 offers in hand, how many of the offer have you failed in order to get those 4 offers? In order to get that 4 offer, might be you would have failed in 16 offers before, which you have not got, and then you have got these 4 offers. That is not there. That data is not there in social media. So as a fresher or as a student, if you read all these, it looks very disappointing, because if you are going through your own failures, right, and if you see someone having 4 offers, it sometimes become very disappointing to see that I am getting so many failures, but the person has 4 offers. I think we all have to understand that everyone goes through those failures, and then only they reach a stage where they have different offers.
The professionals, I would say, have a backup plan. So I've had candidates in my, whom I've been the instructor for, who have 16 years of experience, and they quit their job. And they've been searching jobs for 1.5 years. And so have a backup plan, understand your family situations and people who are depending on you as well. Don't take abrupt decisions like quitting your job and, taking, so always have a backup plan while you're transition. Maybe don't leave your current job, maybe, get your job, you can do the process of parallelly building skills and job searching. And only after you get a job, you can, have some kind of a backup plan. What, even if you're going to take that abrupt decision of quitting a job and searching for 1 year, you have everything else sorted out for you, the family situation and things like that. Be very careful about, because I found some of my students making that mistake. They were out of job for 1.5 years. Finally got referred by somebody he met in a networking event, and he got a job. So have a backup plan. That's very important for professionals. As a student, you might have a lot of time, compared to a professional, so put your time into good use. You can come up with very interesting innovations. Also think through the decisions which you take, how it's going to affect people around you, and take wise decisions. And this is it from my end.
Superb. Thank you so much, Ishita, Supriya, and Usha, for these absolutely amazing insights. Let's dive right into audience questions.
Actually, now I'm pursuing BSc in statistics. I want to become data scientist. I'm wishing to pursue MSc in data science. What my problem is, I have zero computer knowledge. So would I face any difficulty while studying MSc data science?
So I actually similar experience, right? I did my undergrad in physics. I didn't really have much coding experience at that point, and my master's was actually quite coding heavy. So your master's in data science will definitely have especially assignments, any projects that you work on will be coding heavy. So I would recommend at least doing like a very basic coding course before you go, because coding is definitely, that's something that is going to be part of your career as a data scientist, irrespective of whether you're in industry or in research. So yeah, I think either maybe do an open source course available either on Coursera, Udemy, or see if you can maybe take in-person classes with any institute that you have nearby. But yes, I think I would definitely recommend learning to code before you go for your master's.
I come from more of an auto industry plus training background department. And if I have to select a domain, because there's a lot of discussion around which, you have to have good knowledge about your domain also. So let's say I want to transition myself into banking industry. So what are the right steps that I should follow? Or is it an other domain that I should pursue as I'm coming from auto industry? Because what I have realized while restudying data analysis course, I kind of had a relove with my maths. I wanted to do something related to maths during my education, but I couldn't. But now again, when I'm redoing it again, I'm just reliving my school days. I'm enjoying solving problems. So which domain I can go to? The other question would be around, Usha spoke about to have a backup plan. So I believe as a working professional, it's not easy because I'm supposed to dedicate at least 3 to 4 hours daily with all the office works, plus the office have opened up, so I'm supposed to travel also sometimes. So managing a time is a bit challenging. How do I ensure that I do get a job and then I eventually make a career into it? So these are my couple of questions that I wanted to ask.
Selecting the domain, the best thing to do is to go through their JDs. Read nowadays the JDs which get published specifically for data science and machine learning jobs, they are very detailed. So go through their JDs and find out the keywords. They are very specific in saying what domain they are hiring for, and check through those domains if you can connect. If you can connect, then of course you can choose those domain. Also, if you are new to that domain, you have to spend a lot of time in building up the domain knowledge, because you can connect to the data only when you understand the domain. There are a lot of blogs which are written for the domain, for the business understanding of a data science or machine learning problem, and that will be helpful. Also on LinkedIn, there are groups which are dedicated, groups which are dedicated for case studies proper to that domain. If you follow the right set of groups, I think right set of messages will start popping up on your profile itself whenever you are on LinkedIn, and that will be very handy. So those are few things about the domain. And the last question which you asked is about time management. I think time management is something which is beyond, it's not related to data science. That's what I keep saying to any of the mentees which I also have, that if you see that you don't have time, you have to figure out your own time and you have to make up your own time. So be very systematic with your approach, develop your milestone, tell yourself that these are the milestone which I have to develop in this time frame, and then stick to your plan. I think that will help you with your time management, and that's the only way, I think.
And actually, I'm a parent. I'm asking for my son. My son actually a little bit confused. We took a session from Mentoria also. He got selected in ISI. He got an option in ISC also, and then maybe after JEE he will got into any IITs. Now, suppose he want to do as a career in data science, where he has to have, because Ishita, she had a background of physics, and after that she has come to data science. So is it better to continue as a statistics as a main subject, or in pure science like physics, chemistry and maths as a subject, or pure BSc computer science? Which is the best way of doing, if you want to have a career in data science?
See, if your son has got into ISC and the organizations which you have mentioned, I think I would definitely recommend taking it up, provided the specialization which he is taking up, for example, if it is statistics or whatever, he is passionate about the subject because he is to learn that subject for 3 years. So if it's something which he doesn't like, then he may not be able to go through that journey of learning something for 3 years. But since I work a lot with the candidates from IIT, and so right now I see something in their profile like dual degree in metallurgical engineering with minors in computer science, dual degree in physics with minors in data science. From IIT Delhi, I saw a lot of candidates. They have a specialization with minor in data science and things like that. So, I think these universities, they still give you opportunities irrespective of the domain which you have chosen as your main domain. You can still learn these courses. They have provisions for letting you learn the data science specific courses. They have provisions for letting you learn the computer science specific courses as well. So when you take such decisions, ensure the child enjoys the specialization which the child is taking. The university branding also matters a lot, because for certain, no matter, there could be a lot of ethical, legal debating around that and all, but still the employers in India and outside, they give higher weightage and preference to universities from specific thing. They give a lot of preference, and a lot of organizations who come all the way from Japan to hire from Indian IITs. That perception is always there. I think that also has some kind of a weightage, but it's not completely that, but that still has the branding and all that is still there. But the decision has to be taken on whether the candidate enjoys the course and things like that. Data science always can be learned as a supplementary course as well. So take a wise decision. That's what I'd say.
Super. Thank you so much, Usha, for sharing that. Thank you all so much for attending this session with Supriya, with Usha, with Ishita, and with Mentoria. Supriya and Usha, thank you so much for the incredible insights and value that you brought on the table. And I know that this will really help a lot of professionals and students in making informed and accurate decisions. So really appreciate you taking the time out and joining us here today.
We are talking, so we are still involved, but the people who are listening to us are actually having more patience because they are listening to us from last 2 hours. So thank you for attending it.
Thank you so much, Supriya, and thanks to the
entire audience. To the entire team of Mentoria, Nikar and Ketki, and for the audience, thank you so much for my co-panelists, Supriya and Ishita as well. Hope you enjoyed the session and the insights have been useful to you in something. Thank you.
It was a pleasure hosting you, and good luck.